Okay, so now I'm going to start your technical snap on strength of material for PSU's exam, correct?
Okay, sir.
Okay, so how you define strength?
Sir, it is the maximum stress that a material can sustain before failure.
Okay, and what about material?
Sorry.
How you define material?
So engineering materials are defined as those bodies which, when applied with external force, show elastic property. That is, when force is removed, they regain their original shape.
Okay. And what is the difference between rigid body and deformable body?
So rigid body, when force is applied, then no strains are produced. Only stress is produced in those. And elastic bodies, it will elongate. It will show strain.
Is there any stress in the rigid body?
Yes, stress is there.
And strain?
Strain is zero, sir. There is no displacement of fibers, particles.
It means in Hooke's law is not applicable for this.
No, sir.
Then how it is possible? And do you know stress comes because of strain?
Because of strain, yes.
And if there is no strain, then how you get stress?
Sir, but rigid body is something which will not deform, but it will experience the stress. The force between two molecules will be there.
How? Let's say suppose you have two rigid body which is connected to each other. And now if you
Yes.
apply some force on the body one, then how much force acting on the body two?
So the internal resistance force will be generated. So equal and opposite force will be developed.
In the body two, I'm asking how much force acting on the body two?
Means they are connected. How the system is?
Yes, yes, both are connected to each other.
Okay.
Let us suppose you have a box which is put it on the table, correct?
Okay.
And
Yes.
let us assume box and the table both are rigid, correct?
Okay. Yes.
So how much force? And let's say in the box you apply a force in the downward direction by 100 Newton, and
Okay.
box is massless.
Okay.
Then now tell me how much force acting on the table.
So, sir, same 100 Newton will be the reaction force, and the same will be transmitted to the table.
Same force. It means there is no internal resistance force.
Sir, so on the box which is massless kept above, so it will experience compressive force because from below reaction is there which is opposing the top force.
Yes, it will subjected to compressive force, but I am
Yes.
asking how much internal resistance force we have on the box, or sorry, in the box. Tell me. If you apply externally 100 Newton force, then the entire is transmitted to the table, correct?
Yes.
So is there any internal resistance force? Are you getting what I'm telling
Yes,
you?
I got your question, sir. Just give me a minute, sir. I'll think.
There is no internal resistance force. If it has some internal resistance force, then definitely the load transmitted to the table is not equal to the applied force.
Okay.
Is it clear? Is it right or not?
Okay, yes,
आप
sir. I
suppose
got your.
सोचो ना 100 न्यूटन का फोर्स अप्लाई किया, बॉक्स सेम अमाउंट कुछ अमाउंट का अगर रेजिस्टेंस ओवर करेगा तो सेम अमाउंट का लोड ट्रांसमिट होगा ही नहीं कभी.
Okay.
correct?
Mm-hmm.
And if there
Okay.
is no internal resistance force, then how you can say the stress induced?
Sir, but for rigid body, the graph is a straight line following the stress axis. So in that is the rigid body graph, right? So from that I actually told.
There is no stress, correct?
Okay.
Rigid body is a hypothetical body.
Yes.
Such body is impossible to construct, correct?
Okay. Yes, sir.
In the
Understood.
real life, there is no existence of rigid body. This is a hypothetical concept.
Mm-hmm.
Is that clear? And if there is no stress, it strain means there is no stress. Because stress induced because of strain
Strain. Yes.
against the deformation. Clear? You
Okay.
define
Yes.
stress. So it's a stress is intensity of internal resistance force offered by the material against the deformation.
Yes.
Is it
Correct.
clear?
Yes.
And if
Yes.
there is no deformation, then how you can say here you have stress? That's why engineering mechanics, you never study
Rigid
stress
bodies.
and strain. You only study about how load is transmitted from one body to another body. Correct? How much
Mm-hmm.
reaction induced, like this.
Yes.
Correct?
Yes, sir.
Correct. So there is no stress and there is no strain in the rigid body.
Okay.
Okay,
So, sir,
so
could you just explain me that graph which follows a straight line, vertical straight line following that
why are you drawing stress strain curve for a rigid body if there is no
actually I
stress?
see this curve. That's why I was getting confused.
That one is absolutely wrong.
Okay. Okay, sir.
Correct?
Understood that. Yes.
If stress induced, it means it doesn't transmit force. Is it clear?
Yes.
It means it has some internal resistance force. But actually, if I tell you a law of transmissibility of इंजीनियरिंग मैकेनिक्स अगर आपने कोई प्रॉब्लम किया है ऐसा जैसे यही एग्जांपल मैंने आपको बताया कि when one box is put it on the surface and if you
Mhm.
draw the free body diagram then you see in the surface you have exactly same force which is applied
Force.
on the box. ये
Yes.
कैसे पॉसिबल है अगर वो रेजिस्ट कर रहा है
Mhm.
ये कॉन्ट्राडिक्टरी स्टेटमेंट होगा ना फिर
Okay.
करेक्ट
Yes, sir. Understood. Yes.
और ये भी कह सकते हैं दिस इज हाइपोथेटिकल बॉडी एंड ऑब्वियसली कोई भी बॉडी होगा तो हुस्लो तो वैलिड होगा ना
Yes, sir. Understood.
तो वहाँ स्ट्रेंथ जीरो है और आप कह रहे हो कि यस यंग्स तो उसका तो फिर यंग्स मॉडल्स इनफाइनाइट हो गया
Mhm. Yes. Stiffness
है
will
कि
be
नहीं
infinite. Correct. Yes. Understood.
ओके सो ओके हाउ यू डिफाइन स्ट्रेन
It is the change in dimension of a body to its original dimension.
ओके एंड व्हाट डू यू मीन बाय यंग्स मॉडल्स
Young's modulus gives us the idea of the stiffness of that body.
stiffness of the body and what
Yes.
is stiffness
How much it will means for a spring, like how much it will deform for a given force. So that is given by Young's modulus in steel or I mean engineering material.
is there any deformation on the spring
Uh, Deformation. No, it undergoes I mean extension and
deflection
deflection.
correct deflection takes
Yes.
place no there is no deformation actually deflection takes place when
Yes.
you
Yes.
apply load on the spring correct
Yes.
okay so do you know resilience
Yes, sir. So it is the amount of energy stored by a body up to elastic limit.
and what do you mean by resilient material
Uh, Means which can store more amount of energy within that before the elastic limit. Means if it can store very high amount of energy, then it is called resilient body.
Okay. Higher energy stored करेगा तो resilience ज़्यादा हो. And let us say, suppose if I load a sample within the elastic limit, correct?
Okay. Yes.
And then unload it. Then how much residual strains may induce?
For within elastic limit, the body will follow the same curve up to 0. So there will be no strains, residual strains.
There is no residual strain.
No.
Sure.
Yes.
Okay. Now, if you load that body under up to certain plastic deformation.
Yes.
And then unload it.
Yes. So that. Yes.
Residual strains कितनी होगी आप बताओ?
So it will be equal to plastic deformation. So when we draw line parallel to the initial straight line within elastic limit, then we get the intersection on the x-axis, that is on epsilon axis, and the difference between these two lines will give us the strain, residual strain.
Okay, and now again, if you load it, then what will happen?
Then it will follow the second line. Means it will start plastic deformation from new point.
Okay, so what about Young's model? It will change or it will remain same?
No, it will remain same because it has followed the initial vertical straight line.
And what about resilience?
Resilience seems to increasing because no, just a second, sir. Resilience will increase, sir. This is the
and what about toughness?
Toughness is decreasing because the area under the before failure is decreasing, so toughness will decrease.
And what about failure point, fracture point?
That remains same.
Fracture point is remains same, correct?
Yes, yes.
Okay, very good. Okay, so how you define bar?
The member which is under axial loading is defined as a bar.
A horizontal structural member which is subjected to axial load is called as bar.
Yes.
Correct? It must be horizontal.
Okay. Vertical will be a column. Correct.
And how you define beam?
Beam is the member which is under bending stresses or lateral forces.
Yes, a member which is subjected to a horizontal structural member subjected to transverse load, that is called as beam.
Yes.
And how you define column?
Column is a vertical member which is subjected under compression.
Axial compressive load.
Axial
and
compression.
What do you mean by cylinder column?
A slender column.
Yes.
Sir, I'm not sure about the definition.
A column which has very less lateral dimensions as compared to its longitudinal dimension, then it is called as. और कोई भी structural member जिसका lateral dimension longitudinal dimension से काफी कम होता है, that is called as cylinder bar or cylinder column.
Okay.
Is that clear?
Yes, sir.
And do you know slenderness ratio?
Yes, sir. It is the ratio of effective length to minimum radius of gyration.
Achha, let us suppose you have two material. One is aluminum and then one is steel. Correct?
Okay.
And both have a different strength. Even steel is stronger than the aluminum, let's suppose.
Yes.
And if I select EI in such a way that both the materials has same EI, same flexural rigidity, correct?
Yes.
So now tell me, if I talk about critical load of buckling, then क्या होना चाहिए? What do you comment on it? Whether it is same or different?
So, sir, for same length and same end conditions, so it will be same for both the columns. I mean, both the materials.
So now tell me, is it possible कि both column may buckle with same load?
Because it is proportional to EI, sir. So both, if the product is coming same, then PCR, our critical load value according to Euler's formula will be same.
This is the limitation of this Euler's theory.
Okay.
It tells us if you have same EI, whether it is made up of steel or wood, both can buckle at same load, and which is practically not possible.
Oh.
Correct. So this is the limitation. That limitation is overcome by the Rankine. Correct.
Yes. Okay. Yes, sir. Understood.
Okay, sir. So now I'm going to conclude your interview.
Okay,
Correct.
sir.
Your introduction part is good, no issue. And yes, obviously the rigid body or deformable body में difference नहीं पता था. Now you know.
Yes, sir.
Correct. And your stress strain diagram is also correct, no issue.
Okay.
So I think बाकी ठीक है, प्रिपरेशन काफी अच्छी है आपकी, कोई इशू नहीं है, ठीक है ना?
Okay.
ओके,
Yes.
चलो, ऑल द बेस्ट.
Okay, sir. Thank you.
थैंक यू.